Welcome to CS284. I'm your instructor, Robert McMillen, and this is Module 5. And we're going to be talking about host application and data security. Host security is more about physical security and also has some logical security as well. But first we're going to talk about the doors and locks. So there's a big difference between the doors and locks at a residential, at a home, versus a commercial. Typically the residential doors are made of wood or something that's less resistant to any type of attacks, and the residential locks tend to be single locks instead of double ones like the commercial locks are. Also, the commercial doors tend to be made out of steel as well. So there is a big difference in security when trying to secure your computers, your laptops, desktops, and servers at a commercial versus a home. Fencing, of course, is another good way to help to secure your devices. Fence can be climbed, so you do want to think about having some type of possible razor wire or some other spikes, things that would have people be resistant to wanting to climb the fence. And of course, video surveillance is another good way to keep people away from your devices. Whether the video surveillance is real or just a dummy box, either one will keep people from taking advantage of trying to access your building. So there's several different types of locks that we should be aware of. Residential locks, there's the keyed entry, of course, just standard lock using a key to gain access. A privacy lock will also allow you to have a door locked but have a little hatch open into the door so you can pass something through the door. Then there's the patio type of lock, which is the sliding lock, and using a sliding door. And typically those are easily trespassed using the pushing up on the door, up and out, and it just disengages the door. So you've got to think about that when accessing your commercial building. We have several customers who have commercial buildings with sliding patio doors, which of course isn't so great. And then, of course, there are passage locks and dummy locks. Dummy locks, of course, that look like bigger locks but don't actually have any locks on them. And on the commercial side, you've got storeroom, classroom, store entry, double cylinder, communicating double cylinder. So basically, double cylinder would be a type of lock where you've got a lock on the door handle and you've got another lock right above it, which tends to have a longer bolt, which makes it harder to kick in. And a storeroom or classroom lock would be a door where you open the door, and then when it closes it automatically locks, and it always has to be accessed by using a key from the outside. From the inside, of course, you should be able to get out in case of any kind of a fire or that kind of thing. In some cases, you've got there's a requirement to, such as in certain storerooms, that require you to use a key on both sides of that door every time the door opens or closes. Then there's the communicating double cylinder, and that would be a way to communicate with the cylinder itself, and we'll talk about some more of those here coming up. So there are managed locks, which provide an alternate means of access, and you can give control over time of entry. So you can say, all right, you can only come in to a managed lock between 8 and 5, or possibly sometimes on the weekends, and you can have an access control list that also can be rapidly changed. So if an employee is terminated, you can change that access control list and they can no longer get in. So there's multiple different ways, of course, that you can use those type of managed locks. One would be a cipher lock, and a cipher lock would allow you to enter a code in order to get in, which is something you know. It could be a number code, a letter code, that kind of thing. You push in the buttons in a certain order, and then the the door opens at that time. So another type would be a proximity reader. This is typically a card with a little RFID chip in it, and as you get close to the door, then the door just automatically unlocks. Or you slip in a key card and you slide that into a slot, pull it out, and then that could also do it. So that would be something you have. A two-form authentication would be something you know and something you have, such as a password and a card. So how do we secure mobile devices? That is a big question because they're so easily lost and stolen. There are laptops, phones, tablets. Now we've got phablets, of course. There's all different kinds of devices that are coming in different sizes and shapes and very lightweight, of course, to make it easy to travel. Well, for laptops, you can use this built-in security slot that the Kensington has made a big business out of, where you put it into that security slot and then it has a little lock. And you'll see some examples of that in the book, in the chapter that for this week, which is chapter 5. Of course, there are safes and cabinets that you can lock up as well. So when you're not using your device, you can put those into those locked safes and cabinets, and that does add some additional security. Then, of course, if the devices are removed from your person or from your business, then you can have data encryption, such as the built-in encryption, which is in Bitlocker. There's also third-party products like FileVault and AxeCrypt and some other ones like that. And when those devices are stolen, they should be secure enough if you have a good password, or if it requires a other type of certificate or card, then it should be secure enough to keep out of anybody who steals it out of their hands, so your identity will be safe. Then there's tracking software. There's the tracking software and the built-in camera in the device takes a picture of the thief and automatically emails it to you. GPS software will automatically track where the device is, so you can go and retrieve it that way. And then if you don't believe you can get the device back, or if it just goes too far away from you where even if you know where it is, you just can't go get it, then you could do a remote wipe type of thing, which sanitizes the device. And typically this can be done with an application that's installed on the device, or if you have an Exchange server, you can use the remote wipe capability in that. And some anti-malware programs also have a remote wipe capability if you have the antivirus software or anti-malware software installed on the device. So operating system security starts with policy and baselining. What that does is it starts out when you buy the device or get the device. You start to put it into production. You do a baseline to find out what's normal operating for this particular device, and then when it goes out of these parameters, then you know that there's something wrong. So what actions will be taken to achieve the wanted secure environment? How systems should be configured to meet the security policy? These are all things that you need to decide with your different department heads at your company, and it can be different for different types of systems you have. A desktop might have a different security policy than a server or a laptop or a mobile device. So a desktop is probably not going to leave the building as easily as a laptop or a mobile device, and of course servers tend to be locked up in rooms. So you may have a much higher security level requirement for laptops and mobile devices. And then configure, deploy, log, evaluate, and repeat that type of thing in order to make sure that your devices stay within the baseline parameters that you create when you first get the device. So you have to do an assessment of policies that are implemented, and you have to constantly assess those policies because things change so rapidly, and you want to definitely log that information so the next time you have some type of a security incident, then you'll be able to keep that information up to date and you'll know how to respond differently. Patch management is a big deal. Of course, patches are used to patch a lot of different vulnerabilities and bugs that come into system. And in the Windows world, we a lot of times use the Windows Software Updates Service program, which is free, and it allows you to control computers that are connected to the domain, and you can decide which patches you're going to patch computers that are deployed. So that way they don't just go out and get any patch, which may cause additional issues, such as patches can fix an issue and add 2 more issues. So by doing patch management, you can do these tests before they go out to the customers that are out in the office. Usually requires testing before deployment, as I mentioned, and the patch update services can configure updates for managed computers. So you can approve those patches, you can decline those patches, and you can also force patches on people's computers if they are really critical and need to go out to everybody. Windows Software Update Service, as I mentioned, and Mac also Software Update Service. So protecting the operating system, there are lots of different tools you can use. Anti-malware protections. Antivirus, of course, is a must to have. And even if your company decides to not purchase an antivirus program, there is a free Microsoft antivirus program called Essentials that you can get that at least does some protection, although it doesn't do very good zero-day attacks where a virus or other malware software gets installed on your device and there's no signature for it. A zero-day attack anti-malware software will notice that something is not normal with your computer and it will notify you and shut it down, even if there's no signature to block that. And of course, anti-spam is a big one. A lot of viruses come through spam, so you got to make sure you have that before email gets delivered to your clients. And anti-spyware to keep them from being snooped on and possibly have their identity stolen. And firewalls, also a good way of protecting your operating systems. Many firewalls now have the option where you can purchase additional software to go in to provide anti-spam and content filtering, that kind of thing, for your clients behind the firewall. Application security. So any type of applications that you have installed on your computers or on your servers need to be secure, patched, updated. Software development, including web software, you want to make sure you prevent buffer overflows, like we talked about in previous modules, where someone puts in a lot of nonsense data and ends up overflowing the buffer, which could cause Easter egg code to pop up, and that allows people to do things that they wouldn't otherwise be able to do to your servers. How to handle errors and exceptions. Of course, you want to make sure that any types of errors and exceptions are dealt with, and sometimes the programmers aren't going to be aware of those, and you'll have to deal with those yourself or even report those to the software vendor. Test for cross-site scripting and input validation when people put in input into a form that might be tied back to a SQL server. Also includes SQL injection as well. And you can attempt at fuzzing to provoke errors. Fuzzing is where you put in different kinds of data just to see what happens. And once you see what happens, then you can provoke an error in order to learn on how to fix that error. Data security, keeping corporate data inside the company. You want to keep your data from getting out there, and there are lots of data loss prevention software tools. One of those tools is a data loss prevention server that you can then push a client agent out to the different computers. That client agent will then know what's normal and what's not normal for that particular device, and will look for certain things like social security numbers, credit card numbers, things like that. And it will make sure that that information doesn't go outside of the company, or if it does, it at least gets reported. They're reported back to the central server. The central server then takes actions such as sending a message to the administrator to let them know that some of this data just left the building. So it scans outgoing messages, outgoing email messages, storage media, websites, that kind of thing. So this agent gets put on the computer and looks for this type of data that's leaving the building. Then it sends an alert message or it blocks access of the data. So that concludes our Module 5. We've got physical security as well as agents and software patch management. And I look forward to seeing your papers and moving on to Module 6.